So our next questions is asking what are conjugates? Right. So conjugate in mathematics, this word is used in two contexts. The first one will be when we're dealing with binomials which are partly rational, or dealing with binomials which are partly imaginary. I'll write it down here. Which are partly rational which are partly imaginary. Right. And also notice that the conjugate is where we change the signs in the middle of two terms. And I'll use another color. The conjugate is where we change the sign in the middle. Right. So some examples could be x squared plus 4 and x squared minus 4. Oh, that'll just be our expression and conjugate. Oops, that should be square. Okay, and b squared minus a, b squared plus a, root 2 plus 10, root 2 minus 10. Yeah. So these are some examples of the expressions and their corresponding conjugate. Right. And let's say we take the conjugate of x plus 2 and x minus 2, and we multiply them together. So we have x plus 2 times x minus 2. And by applying the FOIL method, we get x squared minus 2x plus 2x minus 4, which gives us x squared minus 4. And notice that two terms, negative 2x and positive 2x, are cancelled out each other during the process. So we only have x squared minus 4 left, which has another meaning, and which is the difference of two squared. And in fact, it's a factor form of a different of method. Of a difference of two squares is always a pair of conjugate. So in other words, we can rewrite this as a squared minus b squared is equal to a plus b times a minus b. Right. So we can always apply this when we rationalize the denominator, and especially when we encounter a square root from the bottom of a fraction. And let's try it with an example. So we got a fraction like this, x over 3 minus root 5. So we need to remove the square root as a bottom, as a denominator, and we need to multiply both numerator and denominator by its conjugate. And things we need to maintain the same value of the fraction. Right. So we have x over 3 minus root 5, and thinking about the conjugate of 3 minus root 5 will be 3 plus root 5. So we times 3 plus root 5 for both the numerator and denominator. Hence, our numerator will be just x times 3 minus root 5, and our denominator will be 3 minus root 5 times 3 plus root 5, which we can see it looks really similar to the formulas above. And so in this case, our a will be 3 and a b will be root 5. So we can apply this formula. Since a plus b times a minus b is equal to a squared minus b squared, so we have actually, let's just switch the x to 2. Right. So our bottom, according to the distribution rule, we just got 2 times 3 plus 2 times root 5. And for the bottom, we just got 3 squared minus root 5 squared. So we got 2 times 3 plus 2 times root 5. 3 squared is 6, is 9, and the square root of root 5 is 5. So our denominator becomes to 4. And as you can see, we got a 2 for numerator, which means we can somehow get rid of 2. So in order to do this, we will write 4 as 2 times 2, since 2 can factor the numerator and denominator. So 2, we take a common 2 out, and a 3 plus root 5 is what we have left in the bracket, 2 times 2. So here we can get rid of the 2. So our answer becomes to 3 plus root 5 over 2. And yeah, I think that's the end of this answer. Yeah, just remember this formula is extremely useful. a squared minus b squared is equal to a plus b times a minus b. Right. So let's leave a comment there. Okay. It's asking the formula of 30, 60, 90 triangle. So there's one important thing we need to remember is that it is a one of two types special right triangle. As you can see, there's a 90 degrees there. And yeah, I wrote it down. One of the two types of special right triangle. And the other types will be the 45, 45, 90. Yep. And let's draw this triangle. So yep. So it is a right triangle, and I'll just call this part A, B, and C. So A is equal to 90 degrees, B is equal to 60, and C is equal to 30. 60, 30. So this type of special right triangle has measure of the hypotenuse that is 2 times that of the leg opposite the 30-degree angle, and the measurement of the other leg is root 3 times of that of the leg opposite to the 30. So that means the BC will be 2 times of AB, which 1 times 2, that will be 2. And AC will be the root 3 times of AB, which means 1 times root 3 is root 3. Yep. And yeah, don't mess the AC and BC up, because always remember the hypotenuse is the longest length in a triangle. And so the next thing will be the ratio. So the ratio of the base to longer leg to hypotenuse is 1, root 3, and 2. Yeah. Oh, and the other thing I need to mention is that it doesn't necessarily be like fixed 1, 2, and root 3. We can multiply each side by same number, and it will maintain the property. So like I say, I want to times 2 for all of them, all of the side. So which means the hypotenuse will be 2 times 2, which means 4. And the AB will, instead of being 1, it will times 2 and becomes 2. And the AC will, the new AC will become 2 root 3. And I call that C star, B star, and A star. Yeah. Remember, as long as it follows the 1 root 3 to ratio, you always maintain the 30, 60, 90 degrees. Yeah, which means the angle, the degree for C star is still 30, and the degree of B star is still 60, and the degrees of A star is still 90. And yep, and also when it comes to trigonometry, it will maintain the same property. So the sine C is equal to sine C star, and we say cosine A is also equal to cosine A star. Yeah. I think that's all we got for this question. And let's leave a comment there. Oops. Good job. Yeah, and I think that's all we got for today. Let me pause it. Yep, so I think that's all we got for today. And if you enjoyed today's Q&As and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. And if you would like to submit your own questions, with these links in the description, remember to leave a like and a comment and share this video with a friend. And this has been Angel from OneClass. I hope to see you soon. Bye.